Andy Grevstedt, Applications Engineer at Tormach, and today we're going to talk about vices. We've recently expanded our work holding line at Tormach to include 2 high-quality vices and a whole slew of work holding accessories. I thought it might be a good time to talk a little bit about the differences in the products to help you make an informed decision as a consumer. For many people, a machine vise is the most common way to hold a workpiece. Now, of course, we'd like you to buy your vices from Tormach, but even more important to us is the idea that whatever vise you buy, make sure you get a decent one. We pride ourselves to go to tremendous effort to ensure that all of our CNC machines meet certain criteria for precision. However, all of that effort is invisible to you if your vise doesn't hold the work straight and true. If it's out of square, if it slips, or if it doesn't fit the machine well, you're going to get poor parts, poor productivity, and general frustration in trying to make things. Remember, you've spent thousands to make sure you got a good machine. Don't undermine your machine investment by trying to save a few $100 on a cheap vise. I'll be talking about the importance of a good vise, some problems to watch out for, and the features that really make a difference. For most people, a CNC vise is the most common way to hold work on your mill. Of course, we'd love you to buy your vices from Tormach, but even more important to us is that you take the effort and get a decent machine vise. So now, let's talk about the importance of a good vise, some features to watch out for, and the things that really make a difference. On my right side here, I have our traditional machinist's vise. This is a high-quality USA-made vise that we've been selling for a number of years. On the left side here is our new CNC-style machining vise. Well, on the surface, the design looks simple. It's actually taken us about 2 years to bring this product to market. Let me show you why. Over on this table is a selection of failed prototypes and sample vices that we've collected over the years, searching for an affordable, high-quality CNC vise. I think what's most instructive is to show you how bad some of these vices can get. For that, I'm going to take this guy over to the other table. What I've got here is a 6-inch vise from a fairly well-known discount house. It'll set you back about $100. Once you get all the grease wiped off, it actually looks pretty good. However, there are a couple things that raise some concern. One is this grind here. While that's mostly cosmetic, it does make you wonder what else you might find wrong with the vise. This is another issue, the lack of chamfer on the edges. Sooner or later, you're going to end up getting nicked by this edge. Right here. Another issue is the lack of chamfer on the edges. Now a high quality vise will actually have a threaded connection for this collar so you can adjust the friction. But what's really incredible about this vise is that even when I remove that particular thing, that friction remains right there. It's still binding. Yeah, it's incredible. You can actually see the screw wobble in there. And right here I've hit a real rough spot. I can hardly spin this thing. That's not a sign of a quality vise. That's really bad. So now I'm going to take a look and see what's underneath this movable jaw. It's held on by this set screw here. So I'm just going to remove that set screw. And once I've removed this screw, the jaw should come right off. Once I've removed that set screw, I should be able to lift this jaw right off. However, I can't even get it off. On a quality vise, this jaw should lift right off. On this one, I actually got to use a little more leverage to get it off. Something's clearly binding here. On this particular jaw, what really jumps out is that this pivot point is cast right into the jaw. This should be a separate ball in a socket in here that helps lock down the vise. Instead, we've got an as-cast surface cast right into the jaw. That's really jumps out and probably the reason why this thing is binding so much. When I've almost completely disassembled this vise, I can actually get to a point where I can look behind this screw and see what's in there. And what I would expect to find on a quality vise is some kind of bearing, probably a thrust bearing. Here I've got nothing. So that pretty much seals the deal on this vise. It's really not worth your time even at $100. It's just not something that you're going to be pleased with at all. When I pull this vise far enough apart, I can actually get behind the screw and see what's behind there. And what I would expect to see on a higher quality vise is some kind of bearing, possibly a thrust bearing. Here I don't see anything. It's just a recess that the screw rides in. That pretty much condemns this vise at no matter what the cost, in my eyes at least. So that's an example of how bad things can actually get. Now I'm going to bring back our CNC vise so we can take a look at some features that you should be looking for in a quality vise. So this is our 5-inch CNC vise, and right off the bat there's a few things we can look at that show well compared to the other vise we just looked at. So the first thing to notice here is the nice grind on all the finished surfaces. If you remember on the other vise, they had some roughness to the grind, which leads you to wonder what the fit and finish is on some of the other parts of the vise. Here we can see a nice bevel on all of these edges. If you remember on the other vise, this edge in particular was quite sharp and would have been easy for somebody to cut themselves on. Here we see a Zerk fitting for lubricating the thrust bearing that's underneath here. The other vise had no thrust bearing at all, so it didn't need a Zerk, obviously. Right here we see accommodations for covering the screw. Machining swarf, coolant, dust, grit, etc. all spells bad news for the screw on your vise. So seeing a feature like that is a good sign on any high quality vise. Right here is the friction collar. This particular collar is held on by 2 set screws. Once I remove these set screws, I can actually thread that collar right off, and the threaded portion allows me to adjust the friction on the screw for this vise. If you remember, the other vise just had a collar and a dimple and actually no threaded portion here. This is the screw that holds the movable jaw in place, and once I get this one out here, you can actually see that this is 2 screws. There's a little cap screw, and in there further is the actual screw. So if I can pull that guy out, and once I have that out, you'll see that the jaw lifts up very easily. Once I've removed the movable jaw, I can look underneath there and I can see that it's well machined and painted in all the right places. And I can see here that the ball is actually stuck on that surface there. So here is the actual ball joint. It's flat on one side and it's round on the other, and it's smooth, it's machined, and it fits right into the recess here. And this particular feature is really a hallmark of a high quality lockdown vise. So that's it. Hopefully that'll give you some pointers on what to look out for when choosing a lockdown CNC vise. In part 2, I'll talk a little bit more about the differences between our traditional vise and our CNC style vise. Thanks for watching. Hi, I'm Andy Grevstead with Tormach. This is part 2 of our vise series. In this part, we're going to compare the 2 vices available from Tormach. On the right, I have our traditional machinist vise, and on the left is our newer CNC style vise. In part 1, we talked about the features that make up a quality lockdown style vise. Both of these are quality lockdown style vices. However, there are a few key differences that I'd like to point out. So we'll start over here with our traditional machinist vise. This vise is a really, really nice vise. It's made in the USA, as I mentioned, and there's just a couple of features that really make this a nice vise. One is the nice powder coating here on all the surfaces that aren't ground. I also like the handle. It's quite nice too. It's a really nice looking piece. It really fits in your hand well. The traditional vise also has this flange style mounting for mounting to the table with just bolts and T-nuts. That's common, as you'll see, in a lot of manual machines. However, with CNC you'll often see a little different style vise, which we have over here. This is the CNC vise. Instead of the flange, it has a machine slot here which fits some hold down clamps. The big advantage of that is it gives you a little more versatility on mounting this vise. You can mount a vise traditionally like this, but you can also, because the flange isn't in the way, potentially mount this vise on its side like this, and that situation may present itself once in a while when you're machining something tall and slender. Our 5-inch machinist vise comes with a report which shows factory measured values for parallelism and flatness of the jaws. The handle on this vise is really nice. Both of our 5-inch vices have a thrust bearing incorporated at the screw underneath here that really make these vices turn easily. So in this vise we see a lot of the things we expect to find in a high quality lockdown vise. There's a thrust bearing encased in here. The screw is covered here. It prevents swarf from getting at it. This vise has a lot of things that you'd expect to see in a high quality lockdown vise. It's got a thrust bearing that allows the screw to rotate freely. The screw is protected here with a metal plate to prevent swarf and machining grit from getting at it. And the screw is retained here rather nicely with a snap ring arrangement. It's really a high quality, nicely built item. Let's look underneath this vise. You can see a really nicely finished bottom surface. It's also got some slots here for optional vise keys. So here's one of them. You can fit it here and here, or probably more commonly here in these two locations here. Really just a nicely made vise. Both vices are ground to 1 thou tolerance on the precision surfaces. The difference in price between our traditional USA-made machinist's vise and the CNC vise that's made overseas is a couple $100s, and most of that can be explained away in fit and finish. With the USA-made vise, you get a really nice machined handle and a really nice powder-coated surface here. With the CNC vise, you get an as-cast and painted handle. When you look at these two handles, you can really see a nicely made machine handle. This is an as-cast and painted handle. It's little things like that that really make up the difference between the two vices. You can see that this vise spins smoothly too. There's no binding whatsoever here. Yeah, it really moves nicely. Here we can see that the vise spins really smooth. It's really easy to actually move this jaw back and forth, in contrast to that previous vise we saw that had an actual really prominent binding point. The painting on the vise is also not as to the quality as the traditional vise. Well, the traditional machinist vise has a really nice powder coat. The powder coat on this vise isn't quite done to the same level. Let's flip this guy over and take a look at the bottom here. And what you can see is it's got machine slots for vise keys here, and actually 2 slots here. You choose which slots you want to use depending on where you want the vise to sit. One works really well for the PCNC 770. The other works really well for the PCNC 1100. This vise has also got 6 tapped holes, 4 at the corners and 2 in the middle. That's so you can fasten it to a subplate or trunnion. Both of the vices are drilled and tapped for an optional work stop accessory here and here. Here's what that looks like. The traditional machinist's vise fits really nicely on the 1100 and is just held down to the T-slots by bolts on the flanges here. The CNC style vise, on the other hand, uses some clamps that grab onto the slots machined in the side to hold it down. can also mount two CNC vices together. As you can see from this setup here on the Tormach PCNC 1100, there's room for 3 5-inch CNC vices on the table. On the PCNC 770, the traditional machinist vise hangs just a little bit too far off over the back. So that about does it for part 2 of our 3-part vise series. Let's take one last look at the vices again. On the right here is our traditional machinist vise. It's a 5-inch design. We've got the optional work stop attached here. And on the left is our brand new CNC style machining vise. In part 3, we're going to look at a couple different jaw accessories that will work with either one of these vices and actually most 5-inch standard vices. I'm Andy Grefstedt for Tormach, and thanks for watching. Vices can be equipped with a number of different jaw types to suit individualized machining applications. Hi, I'm Andy Grefstedt, Applications Engineer with Tormach, and today I'm going to show you a couple of different vise jaws that we can put on both our 5-inch traditional machinist vise and our 5-inch CNC style vise. This is part 3 of our 3-part vise series, so let's get started and we'll take a look at a couple common jaws. The first and most commonly used jaws are just the hardened steel jaws that come with your vices. We also have these in a couple different thicknesses. So these are the steel step jaws. So the steel step jaws are designed to support and locate your work vertically in the vise, like so. So the next type of jaw I'd like to show you is the V-block. And the idea with this is it's got a number of different triangular grooves, relieved grooves in here that are designed for holding round stock. Let me show you how it works. When you set it in your vise and tighten it, I've got my round steel bar here, and it's got a large V-shaped groove in the center. When you tighten it down, it'll grip that stock just like so. It's perfect if you want to do thread milling or any type of application where maybe you need to do some work on the end of a bar. It also has 2 secondary grooves on either side of the main groove, and those are handy if you want to hold 2 bars of the same size on either side of the jaw. And the last way is it's got horizontal grooves in there for holding round bar like this, and this is great if you want to drill radial holes into round stock or something like that. So the V-block is a real handy jaw. Another type of jaw that you'll often encounter are aluminum soft jaws. Aluminum soft jaws, in contrast to the hardened jaws we looked at earlier, are designed to be cut by a milling cutter to provide a custom work holding solution for whatever you want to hold. We not only have the standard 5-inch aluminum soft jaws, but also the extra long, extra thick jaw blanks. So if you want to hold something that's a little bit larger than your vise, look no further than these big guys here. Here you can see we're using the aluminum soft jaws to hold this part. We've actually milled out some places here to put clamping pressure appropriately right there and right there on that part and hold it firm in the vise. So the final jaw I want to show you today is the pin jaw. This is a neat idea. It's got a lot of different holes in different patterns on the face and removable dowel pins. So what you do is you take out the pins and leave just a couple. You put it on your jaw like that, match it with a flat jaw like the soft jaw I have in there, and then when you close it, it'll accurately position your workpiece at an angle to horizontal. So a handy item to have when this particular situation arises. So that's it. That's a quick rundown on 5 different types of jaws that'll fit either one of our 5-inch machinist vices. Thanks again for watching. I'm Andy Grevstead for Tormach.